Okay, so hello everyone. Today in this video we're gonna discuss about basically the direction of reaction, right? So first of all, here you have to remember the direction of reaction is defined by the quotient Q. Now, what is the quotient Q? It is basically the ratio of, we can say it is the ratio of the concentration of product to the reactant. Okay. Now the direction of reaction is defined by quotient, which is Q. Okay, so now what is the Q? Q is basically the ratio of the concentration of product upon reactant. Ratio of concentration of product upon reactant at a particular time. So that is known as reaction we can say quotient. Now the reaction quotient is, we can say, obtained by what? So reaction quotient is basically obtained by applying, we can say, law of mass action. Obtained by applying law of mass action. Law of mass action. So here we have what? Q is equal to product upon reactant. Now let's discuss some of the possibilities of Q. Okay, so yeah, number one, if I can try. Okay, so here we are going to discuss about some of the qualities of Q. So first quality is Q is less than K. Okay, when Q is less than K, so this indicates, basically in this it indicates the product is more, product ज़्यादा चाहिए, more product is needed to acquire the equilibrium. This means कि इसमें ज़्यादा product चाहिए equilibrium achieve करने के लिए. More product required to achieve the equilibrium. Okay, same. Now in this condition, the system will shift to the right side to achieve the equilibrium. Okay, this means from the product, we can say, reactant to product, it will shift to the right side. Shift to right side. Okay, so now let's talk about, we can say, another possibility, which is Q is greater than Kc. So now in this condition, what will happen? So in this condition, the more reactant is required. इसके अंदर ज़्यादा reactant चाहिए so that our can be achieved. More reactant is required. Okay, so in this condition, we can say the system will shift to the right to achieve the equilibrium. Shift to the left, sorry, not right. Shift to the left. So now let's discuss about third possibility, in which Q is basically equal to Q is equal to K. Q is equal to Kc. So yeah, I know everyone know this. Whenever Q is equal to Kc, this shows that reaction is at the equilibrium position. Reaction equilibrium position पे पहुंच चुका है, and here no shift will occur. No, either the reaction will take place on the left side, not on the right side, because here equilibrium is achieved. Okay, so yeah, I hope this is clear to you guys. Now let's do some of the questions regarding this direction of reaction. So now let's solve some of the questions regarding this direction of reaction. Our first question is basically, we can say, yep, here we have, if for the synthesizing of ammonia, synthesizing ammonia at 500 Celsius. एक अमोनिया सिंथेसाइज करना है 500 सेल्सियस पर, where Kc is given, which is equal to 6.0 into 10 raised to power minus 1. Okay, so now the reaction is N2, which is in the gaseous form, plus 3H2, which is also in the gaseous form, will give product 2NH3, which is also in the gaseous form. Okay, so now let's solve this. Fine. So now the solution of this question will be, first of all you write the Q, which is the direction of reaction, and I know you remember to write the Q, which is product upon reactant. So this is the product, so I'll write as NH3, and you know the coefficient will go to the power, it will be 2. At the down denominator we have N2 reactant and another reactant H2, the coefficient will go to the power. Okay, after writing this, just add the values. So here the sum of the values are given, which mean here, if I can write here the values, so it will be what? H2 is equal to 1.0 into 10 raised to power minus 2 minus 2. Okay, another we have N2. N2 is equal to 1.0 into 10 raised to power minus 3, and last NH3 is equal to 1.0 into 10 raised to power minus 3. So now write these all in this equation. So let's do that. Okay, so here we have Q is equal to, first NH3 was equal to 1.0 into 10 raised to power minus 3 whole power 2. With that N2 was equal to 1.0 into 10 raised to power minus 3, and we can say H2 was equal to 1.0 into 10 raised to power minus 2 whole power 3. Okay, so yeah, here we have Q is equal to, here you can see minus 2 will be minus, it will be minus 2 3 minus 6, here it will be minus 6. They both will be cancelled from each other, and here it is remaining 1.0 into 10 raised to power minus 3. It will go up and it will be change the sign 3. So this means Q is equal to 3, and Kc was given in the equation, which was equal to 6.0 into 10 raised to power minus 3. So from these equations the Qc is greater. So this means Qc is greater than Kc. So this identify the reaction will, this means the more reactant is required and reaction will shift to the left side. More reactant are required. I hope this is clear to you guys. In the next video, we're going to discuss about the extent of chemical reaction. Till that, bye bye.